Alright, so we're going to start talking about transformations, and there are four types of transformations we're going to talk about. Them being translations, which are a slide. The second one is a reflection, which is a flip across a line. A dilation is when we enlarge or reduce a figure by a particular scale factor. And a rotation is when we turn the figure either clockwise or counterclockwise some degrees. This video is going to cover number one, which is translations. Alright, so here are your translation notes. You should be going with me and kind of filling that in. The figure, before we get started, we have what is called a pre-image. And the pre-image is the figure before a transformation occurs. Okay? And it's denoted by some letters, and it's just the capital letters to name the points. So, for example, I could just have three letters for a triangle, so it's going to be denoted by A, B, C. All capital letters. And then we have what is called the image. And the image is what you get after you do a transformation. Now, this will work for all four transformations that we'll talk about. So you start off with the pre-image, what happens before, and then the image is what happens after a particular transformation. And an image is denoted by the same letters, but they have what's called the prime symbol. So it'll look like A prime, B prime, C prime. So the way you know which one was the original or the pre-image versus what is the image or what came after we did something is the difference between the primes. So now, what is a translation? Remember that a translation is a slide in the coordinate plane. We're just going to pick the figure up and kind of shift it up, down, left, right, or some combination of all of those. Okay, so a translation is a transformation that moves all points of a figure the same distance and in the same direction. So in doing this, the size of the image doesn't change. So if you look at this picture here, here would be the pre-image, and we know that because it's just straight capital letters, versus this one is going to be the image because it has the prime symbol. So we know this one over here, the pre-image, was the original figure, and after the translation, after it was shifted or slid across the coordinate plane, we ended up with P prime, Q prime, R prime, S prime, T prime. Okay? So on our coordinate plane, we have our notation, which starts off with XY, so that's our original ordered pair, or the ordered pair of the pre-image. And then the arrow says what it's going to. And then we kind of act on, we take whatever value for the X value, and we add whatever it says to do. And then we do Y plus B, and B is the change that's happening. And remember the A, or here with the X values, remember that's left and right. Remember the X axis runs horizontally. So if the object says move to the left, you're going to subtract the value. And if it says move to the right, we're going to add the value. Similarly over here, if you're going to, for the Y values, it's going to move, that's your up and down. So if it's going up, you're going to add. And if it's going down, then you're going to subtract. So, for example 1, we want to translate the figure to the right 2 and down 3. So we want to write the notation of the rule. We start off with our regular coordinates x, y. And then because we want to move to the right, which is say positive to the x value, we're going to do x plus 2. And then since our y value says go down 3, that means we're going to take our y value and subtract 3. Okay, so this is our rule. We start with our original. We're going to add 2 to the x value, and we're going to add 3 to the y, or subtract 3 from the y value, excuse me. So, one way to figure that out is if we're just giving our points of our pre-image, we can go ahead and use our rules to figure out the image. So here, we know that A is at 3, -1. So in order to figure out the others, we are going to take 3, and then we're going to add 2. Because we're going to take the x value and add 2. And then we're going to take the y value, which is -1. Oops, -1. And we're going to subtract 3. And so 3 plus 2 is 5. And -1 minus 3 is -4. So what this is saying is that the image for A following this translation should be at 5, -4. Now let's test to see if that works. Over here on your picture, here's A at 3, -1, and the rule says we wanted to move right 2 and down 3. So you can also just count, move to the right 2 and down 3. And this is where we can place our point. And so that's where we shifted A. So now we're going to call this point A prime. Okay. So let's try it again with B. So B is at -4, 2, which is right here in the graph. And so the rule is still the same. We want to add 2 to the x value and subtract 3 from the y value. So we do it over here to show our work. We can have -4 plus 2. And then for the y value, which is 2, we're going to subtract 3. So we know our coordinates should be at -4 plus 2, which is -2, comma, 2 minus 3, which is -1. So we know that B prime, after this translation, should be at the point -2, -1. And you can check yourself by, let's counting on the graph. So here's B. We want to move to the right 2. So we have 1, 2. And we want to move down 3. 1, 2, 3. And this is where we're going to place our point. And then hopefully you see we are at -2, -1. And we can label this point B prime. So go ahead and pause the video for a second and go ahead and find C prime using the rule and then seeing if you can plot it on the graph. Alright, so point C should be at 3, 1. Also, if you plotted it, C prime is over here again at 3, 1. If you would have went right 2, down 3. And so now you can see the new triangle that is formed, and it's the same size. Size didn't change. The orientation didn't change. All it did was slide to the right 2 and down 3. Okay. Alright, so example 2 says, given the translation defined by xy goes to x plus 2, comma y minus 9, determine the pre-image of the coordinate 1, 8. So now we are given the image. So this 1, 8 is not our original point. It's the point that happens after we did the translation. And this question is asking us to find the pre-image or the original point. So in order to do this, we need to do the opposite of the rule on the image coordinates to find the pre-image coordinates. So what we're going to do is we are going to take the coordinates of the image. So we got 1, 8. And so we're going to do the opposite of the rule. So the rule said 2 plus 2. So we're going to subtract 2 to go backwards. And then the image y coordinate is 8. And so in order to go to find the original or the pre-image, we need to do the opposite of -9. So we're going to add 9. Okay, so then if we have 1 minus 2, that's -1. And then we have 8 plus 9, which is 17. So that means the coordinates of the pre-image are negative 1, 17. Okay, so this is the coordinates of the pre-image. So let's try that one again. We want to, given the translation defined by this rule here, where we had to subtract 3 from the x values and add 4 to the y values, we want to determine the pre-image of negative 3, negative 1. So this is the image. This is what happens after the translation. We want to find, well, what's the rule? What is the coordinate before we did apply the rule? So again, we're going to take the value. So we take the x value, which is negative 3, and we're going to do the opposite operation. So this one said to subtract 3. So to go backwards, we need to add 3. And then we're going to do similarly for the y value. So the y value would be negative 1. And we're going to do the opposite. So here it said to add 4. So now we're going to subtract 4. And so then we have negative 3 plus 3, which is 0. And then negative 1 minus 4 is negative 5. So that means the pre-image of the point negative 3, negative 1 would be 0, negative 5 if we followed this rule. Okay? And that's the end.